We're also going to hear from Josh. He works for Groundsure, who are an environmental search company. And when I bought my current house, the solicitor I used actually bought my property report from Groundsure, and I was probably a little bit too excited, but I knew full well that FME had played a part in producing the report. For Josh, FME is the tool he uses to pull data apart and stuff it back together, and we're about to hear about one of his projects tackling historic land use data. Josh Keys at Groundsure.
Hello. Can you see my presentation there?
Absolutely seamless. We've got you.
Okay, fantastic. Okay, so yes, as David said, my name is Josh. I'm a data research specialist at Groundsure down in Brighton. And most of what I do is kind of data acquisition, data analysis, data transformations, and a bit of product development stuff. As you mentioned, Groundsure produces environmental reports, mostly for the conveyancing sector, but we also provide environmental data to a variety of clients. So that's environmental consultants, architects, engineers, surveyors, that sort of thing. Now, one of our most important data sets is our historical land use database, or HLUD, and this data was derived from scans of old Ordnance Survey maps, sort of dating back to the mid-1800s. You can see an example of it on that first slide there. And the features were digitized by essentially tracing directly from the maps, which means that you've got some features that are recorded several times because they appeared with each revision of the maps covering that area. And so this makes for some fairly busy maps. And perhaps more awkwardly, it results in some quite busy data tables, especially when you've got a paper report. This is sort of lists and lists of stuff. It makes it quite difficult to use. So the aim of this project was to simplify the data so that when we've got a single feature present for several decades, we will display it only once and then give it a date range rather than have it be there several times, which sounded quite simple. And of course, it wasn't that simple. So the initial suggestion was just dissolve it. We could use a dissolver transformer grouped by the land use, which we have as an attribute there. And then the dissolver could create us, let's say, a list of dates, and we could get a date range using a list range extractor or something like that. Sorted, that's problem solved, but unfortunately not. So not all of the features that intersect and share a land use necessarily belong as a single feature. So in this example, we've got a plant nursery that was present for several decades, and the extent's never really changed. It's in the HLUD 3 times, and the features can all definitely be grouped together. It's clearly the same, and we don't really lose any information by dissolving their geometries together, because any differences they've got are superficial. So that's all fine. This site, on the other hand, this is not one we'd want to group together. So this is the site of Norwich Airport, and it's changed in extents quite a lot since it was Horsham Faith Aerodrome. If we were to indiscriminately dissolve the 2 large, very different polygons, then we lose information about the way the site has changed over time, and that's information that can be very useful for some of our clients. So this leaves us with a problem. How do we decide which features belong together in a way that doesn't take huge resources to analyze and doesn't become too complex to maintain? And so this is the challenge that I was faced with. And the workbench that I created didn't look too complicated to start with. Obviously, as I checked the outputs and then received new specifications and rechecked the outputs and applied new filtering and validation, it gradually became more complex. Not forgetting that there's a nested custom transformer that turns up a couple of times there as well. So what is actually going on here? The first step was to create prospective groups. So we do that simple dissolve that I mentioned earlier, and get hold of the IDs of all of the features that go into each group. So we keep hold of those in a list, and then we create a new ID for that group. We then, using the list exploder, get all of our original features back, but they've all got an ID that links them together, that group ID. So then we run so then, yeah, use that to get the original features back. And now that we've got the prospective groups, we need to check whether all the features belong together. So the airport example from earlier would currently be forming a group, which we don't want it to do. So after creating attributes about the geometries, such as the area and the perimeter, we run everything through a statistics calculator, which gets us the averages and standard deviations of those things in each group. We then check that features in a group are within a tolerance to see whether they belong together. And if they don't, then the group fails. Not just leaving it there, we then put it through the custom transformer that I made, the feature group splitter, which splits the group down and allows us to check to see if the features that would go into that group can form a couple of discrete groups. So we might not be able to turn 5 features into one, but we might be able to turn it into 2, for example, which is still better. And then we validate it again. All of this processing and some more aside, for the entire UK takes a lot of processing power and a lot of memory. I was limited to a single one scalable machine that was running FME desktop. I didn't have access to FME cloud or anything like that, so I frequently had timeouts. To deal with this, I built a workspace runner that would run sort of the main workbench that does all the work, a segment of the country at a time. The unfortunate thing is that there isn't a way to split this data up geographically. If you were to split it up using a grid or anything else, then you'll have some features that are picked up multiple times, or you'd have some features that would be missed. So what we do is features that are on the edge of their segment get written out separately to everything else, and our workspace runner reads in all of those edge features at the end and deduplicates them. So beyond just seeing how features relate to each other, the workbench had to address some other requirements. These sort of turned up as the project went on. So for example, features that are on the edges of their historical maps are usually strangely squared off. You can kind of see this site here, it's made up of a bit of a grid. And because the grids that the Ordnance Survey used for creating the maps changed a lot over time, this can cause issues with grouping and can end up with some quite weird looking features. So this section quite early on of the workbench tries to group together features that are on the edge and actually should form a larger feature, and that like simplifies the process further down. We also had the issue, particularly with things like tanks, oil tanks and things like that, where a feature may have been installed, then removed, and then reinstalled later on. That's always a risk with data like this, and we can't always say for certain whether that has happened or not happened. But if we've got a map that shows this happening, we don't want to hide that by just ignoring it and putting a date range that suggests this tank has always been here. So this part of the workbench has to check back the extents of our original map library and look for maps that sort of in the middle of that period for a feature and see if it may have been missing, in which case we'll have to split the group out into 2. So in terms of what's next for us with this project, we can simplify the project for maintainability and readability. So yes, I've got an example here of what this might have looked like in FME 2015, which is where I first started work with FME. Obviously, it's exaggerated it a little bit, but there's lots of aesthetic changes to FME, particularly in 2019 and now with 2020 as well, that made keeping the workbench more organized much easier than it used to be. But yes, so in terms of simplifying the workbench for readability, for example, currently it performs processing on big temporary groups, and then it joins these back to the original data to get us what we need for the output. And while this is fairly performant, it's one of the main sources of untidiness, where we have connectors crossing each other and that sort of thing. It also means lots of extra transformers for feature joiners and feature mergers and the like. So a more effective use of lists might allow the workbench to look more streamlined and easier to follow. The colored connectors feature that David was talking about earlier, it's a small feature, but it could make those crossing connectors much less problematic. More importantly, performance improvements are always welcome. So the changes to the statistics calculator could have a big impact on this particular project, and also improvements to the GeoPackage readers and writers. I tend to use GeoPackage for saving out temporary data, so that's really useful for me. And one more thing, one thing that I feel like I'd quite like to see maybe in FME is when you have got crossing over connectors like this, and it's not, especially because I use squared connectors, it's not always clear exactly which connectors are going which way. I have a tendency to misuse tunnels like this to create a sort of bridge, so that when you're zoomed out from the workbench, you can clearly see which connector is going in which direction. If there was some visual cue that kind of cropped up in on the canvas when this happened, that'd be pretty handy, because as David said, sometimes you can rearrange a workbench to make sure there's no crossing over, and sometimes it's just not possible to do that. So that's all from me. Thank you very much.
Thanks very much, Josh. That's great. The last topic there, I mean, from a style perspective, generally, how do you feel about tunnels? For people who haven't used them, they are just a way of sort of effectively visually teleporting data from one part of a workspace to another. What's your opinion on them generally, Josh?
I think that they've definitely got their uses, but I don't. In this workbench, actually, there is an example where I have a couple that go from one end of the workbench to the other, but I didn't really like doing that, because I think it's quite easy to lose where the flow of data is happening. Something sort of disappears and then reappears later on. It's not always easy to see where that is. Obviously, you can find it by clicking on the start of the tunnel or whatever, but sort of if you're just doing an overview, it's not so easy to see where the data is going. So they're useful, but I think they're probably best used over quite short distances within the canvas.
Okay, and what about so we've got a question around the duration of effort that you put into this process. Is it a work in progress? Was it a work in progress for quite a long time, or did building that workspace take you 2 days or 2 weeks? What sort of level of effort has been put into it?
It ended up taking quite a long time. The initial stages, it was quite quick to get something working, but there was lots of revisiting it and making small tweaks over quite an extended period of time. So I might have, a few weeks of not working on it, and then some feedback would come back from the product managers about how the data was looking, and we'd sort of reassess and sort of add features or take features away. But yeah, it could be fairly intensive at times. So yeah, sort of worked on it on and off for about 6 months.
Okay, thank you. Yeah, and you've got some really good positives comments in here. We've got a couple of messages saying that your map color schemes were a visual treat. So thanks very much, Josh, for putting that together for us.